Hello.
Hi there.
Hello.
I think I'm going to do a quick switch, everybody, because of the light behind me. One quick sec.
Hi, Ken. Hi, Dominik.
Good afternoon and good evening, right?
Good morning, everybody.
Good whatsoever, wherever in the world you are.
That's true.
Right? So I'm coming in from Detroit, Michigan. It's 6 a.m. here. It's completely dark. So welcome, gentlemen. So I'm going to kick this off just introducing myself. I'm Angie Szerlong. I work for SME, which is also host of the Rapid Plus TCT event. And I'm our industry manager in additive manufacturing. I've worked in the field since 2004, working primarily in events and getting to know many of the great people in this industry and getting to know the technologies as well. So I'm honored to host this panel this morning, and I'm going to pass it over to Dominik, Max, and then Ken to do introductions of yourself.
Hello, everybody. It's me, it's Dominik. I'm working for Additive Minds for EOS. I started 11 years ago as an application engineer, so I'm working closely to the system, to the material, to the process, and I know how to use the machines. And since 5 years, I'm the Additive Minds group to do projects with our customers, basically on application development and design for additive manufacturing.
Hello from my side. My name is Max. Good morning, good afternoon, good evening, good whatsoever. Thanks, Angela, and especially to the US people for being awake that early. So yeah, my name is Max. I work for the company Dyemansion. I started my journey in 3D printing at Dyemansion 4.5 years ago. I'm responsible for sales and business development in the European, Middle East, and Africa region, EMEA as it's called. And yeah, I really developed a passion for 3D printing and especially for post-processing, of course. And my vision and my goal is that 3D printed parts become, more relevant products in our everyday lives. And this is what I fight for, let's say, yeah. And I'm happy to be here at the Fireside chat with these lovely people.
So much.
Okay, I guess I'll take it from there. I'm going to start a little differently. Happy Tuesday, okay? Because I think we're everywhere in the world is now Tuesday. You know, for Angie and I, extremely early in the morning. I get a little bit more sun in New York, which we're currently calling the COVID capital. But I like to think of myself as a 3D printing enabler. I'm a polymer materials engineer with UL, been there 30 years. Worked on an assortment of electrical, electronic categories, as well as hazardous location and other equipment. And just because the part or piece is 3D printed doesn't mean that the material needs to change. It still has to meet the same performance level. So my idea is to, or not idea, but what UL is trying to do is enable 3D printing to reach that same level of industry as traditional practices like injection molding. Angie, back to you.
And I have to ask, is that real background?
That is real background. I am a koi pond enthusiast. So in my spare time, my koi pond runs.
Very, very cool. We had other people asking on the chat, so I had to start off with that. Anyhow, so to kick this off, I'm going to go back to you, Ken, as you are the person who's qualifying for color qualification. Can you tell us what would help a company develop a color qualification that would, like, what have you went through so far that you could help others to begin to start their journey?
Yeah, well, I guess, you know, this is one thing that, you know, with Dyemansion and others, we can help is where we approach color very, I try to think as realistically. We divide colors into 3 things, inorganic pigment, organic pigment, and then we actually separate out carbon black. So when we do our evaluations of materials, we're typically measuring 4 colors, a natural or unpigmented state, the natural product that's produced in the case of 3D printed. And then we're looking at the heaviest inorganic pigment, which is typically a white, titanium dioxide. Then we're looking at the heaviest organic pigment levels, could be red, green, yellow, blue, whatever that highest level loading is. And then we're also looking at a carbon black, which we allow a little bit higher. And by measuring those 4 colors, we establish parameters that enable all color production. And companies like Dyemansion can evaluate things like that in those 4 colors in the extremes and know that they can make every color in the spectrum as long as they stay within those guidelines. That answer the question?
You did. So I was going to turn the same kind of question over to Max, as you're the company producing the colors. What would you add to that?
So first of all, so we are not producing the colors itself. So we are more creating recipes with these colors that we get from the big color suppliers. I think these big color suppliers then will do these tests as Ken described. So we just create the recipes around it. So we work very closely together with our customers or with AOS and special applications around that, to make sure that every of our customers gets the color that he is desiring. So, which means that we create the recipe according to their material, if it's a hard, flexible material, and according to their surface finish, because our coloring process is a different one compared to spray painting. So as we are not adding or removing material, it's always about a chemical reaction between the actual dye stuff and the part and the surface. And together with that, we are able to create recipes that in the end meet the requirements of our customers.
Okay, so pertaining to that, could you elaborate more on the start of, so if coloring's at the end of it, post-processing, could you step in and explain how post-processing then becomes part of the beginning decision with coloring as it relates to color?
Yeah, so one thing that is really important if you take a closer look at our process is, as I said, it's a chemical reaction. So, and it can be described as additive coloring, which means that our color always sets up on the base color of the material. And so, for example, if you have a perfectly white part, then for us and our customers, it's the perfect way to start, and it's the perfect way to have like the full variety of colors. If you, for example, have a grayish or an already black part, you can only get darker than that. So there you should already in the design, or even if you think of different printing platforms, take into account that if you have a white part, you can achieve any color. If you have different colors, it might be a little challenging, let's say. And on the other side, it's also very important, and this is where I'm very happy that Dominik is here with me, because already, if we talk powder-based, you can create let's say subjective color variances, just how you create or how you print the part in the printing in the printer itself, how you orientate it, in which position is it printed, what is your powder mix ratio. So this all in the end might have an influence on how the color appears to the customer or the end user.
Dominik, do you have anything to add to that?
I like to add something on that. So as we're in projects, and holistic projects, I want to give you an example for EvoBoss, for example. So it's like interior parts. There it was very important to, for example, for the texturing, to do some DOEs, design of experience, to define the texturing of the part, which is in the end the design of the part. And so we go from design to the additive operation. You need the orientation, like Max said, and you do the AM process and the post-processing. And by defining the texturing, you might have a different subjective feeling about the coloring, especially if you have light gray coloring. The texturing itself might have an influence on your subjective feeling on that. And so it's like, for me personally, it's very important to have a holistic view on that, and especially in the application development phase, to define a robust process which leads in the end to parts which can be qualified actually and fulfill the requirements from a haptical, from a subjectical, optical, mechanical point of view.
So Dominik, back to you. What are the challenges that the end user normally experiences? Because EOS typically then is working with the end user. What would you say the biggest challenges are?
Yeah, yeah. The biggest challenge, I would say, is okay. Let me say it differently. It's like the difference between invention and innovation is implementation, right? So how do you start? How you want to start? So finding the right parts, which creates momentum inside your team, which creates a good feeling. So people are willing to learn more. Know-how is a big challenge, and by doing this, you always need to have a management commitment. So this is, if you don't have management commitments, you can't go further down the way. So I think one of the main challenges are the management commitment, a holistic view on the project, and also people who are dedicated to learn and build up know-how. And this is where we as Additive Minds come into, help you, guide you to create this momentum.
Max, do you have anything to add to that? What you feel are the biggest challenges?
Not really. So I think it's all about, as Nick said, about the holistic approach. So you need to make sure that you understand how design, build, and finish interact, because in the end, these are the key drivers that will make your application successful in the end. And this is what needs to get into the mind of people, that 3D printing, it's not easy, right? So it's more or less a rocket science, and you need to understand that. You need to be aware of that, and you need to make sure that you understand all, let's say, relevant key stakeholders in this new technology. And this is why I think Dominik hits the nail here.
So Max, you mentioned from the start of design. Would you elaborate on that? Like how individuals could design from the start to the end of post-processing for color? Like how important is from design to how to get to the very end?
Yeah, it's very important that already in the benchmark stage or in the very beginning that you need to make sure that everyone has the same amount of information. So everyone knows where are challenges, where are risks, where are chances also. And so you need to make sure that that all, even in the benchmark phase, everything is interacting perfectly. And then, and this is my opinion, it's very important that you freeze processes, that you make sure that the parts are always printed the same, always designed the same. Once you said, okay, this is the part that I would like to have in the end. And as Dominik explained in the case we had with Daimler and their EvoBus department, this is what made us successful in the end. It was all about freezing processes and making sure that we always use the same parameter sets for each of the different parts.
Ken, you're nodding your head over there behind that beautiful pond.
Yeah, like I said, I agree with completely what they say, and not only tying down the process, but tying down the machine to the material to the process, all three. So I completely agree. And the post-processing step that companies like Dyemansion are using, that's also part of that whole process to understand the performance of that part after it's actually produced.
All right. So what would you all, if we talk about design, we talked about challenges, what would you all say is the biggest trend in color qualification or the use of color in 3D printing?
Then you first, if you would like to say something.
Yeah, we are starting to see more and more, submittals of material in color. Not your just traditional black or traditional white. We're starting to see different submittals, and we're starting to evaluate those things. And we are seeing some slight differences between the colors, as expected. Performance on things that in the E&E market, as we're trying to progress into the E&E markets and other markets as well. Color is becoming a big important factor. So these customers do want that color in their product to be able to have that same feature that they've been having with injection molding.
Yeah. Can I add something? Yeah.
Yes, please do.
Fully agree. For me also, there's a huge difference to having a white part, a prototyping part, and by coloring it, it's going to be a product. And let me explain it from a parts training and parts training and selection workshop. That's usually the entry point for us. trying to find the right application for the customer. It's like, sure, it's material, based on materials, based on the size. Can you put it in the machine? Is it critical? But also, is the part visible? And without color, you can't just put that filter. So today, with color, we are able to have applications which are visible. Think about the BMW case. So right in the dashboard, you see it all the time. You see the surface, you see the color, and it needs to fit to the corporate color. Or think about eyewear application, consumer products, or think about orthesis for adults or kids. So these are all applications which are not possible without colors actually. So I think there's a huge trend, industry and consumer-wise. At least from a part screening selection point, we can click the filter visible parts, right?
So two applications that we spoke in preparing for this presentation that I would really like for the audience to hear. And Dominik, you had just slightly mentioned one, but I would like to have Max turn it over for the medical application that I thought was fascinating, that I think that the audience would really enjoy hearing.
I think you're speaking of the company that is also based out of Bavaria, named Polik. So it's an orthesis and prosthesis company specialized on exactly these products, but for kids. And I have had a very heartwarming story to share with you around this, and it has a lot to do with 3D printing and especially color, because what they made is it's a perfect example for mass customization. So kids, they would like to have their very own orthesis part, and they even offer orthesis or prothesis products where you can integrate, like for example, Apple Watches or different let's say fashion devices. And once there was a kid, he or she, I don't know the gender, but I have to be correct in terms of gender equality. So he or she went to school and forgot his orthesis, where an Apple Watch was integrated. And the cool story about it is that the kids were not asking where his orthesis part is or his medical device, but they were more asking, hey, where is your watch? And this is something that I think is very special and only possible with 3D printing and mass customization, because these products can be one of a kind. And if a kid likes soccer, why not integrating some soccer balls or tennis balls whatsoever into these medical devices to make it more like a fashion product than a medical device. And yeah, I can also fully agree with Dominik. So we clearly see a very big trend in terms of color. I mean, we started off with 17 standard colors, and as we created an automated process from cleaning to coloring, we were able to also meet color systems like RAL colors, Pantone colors, you name it. And it's very interesting to see that our customers that started with us in the very beginning 5 years ago, they were ordering standard colors because we had standard colors. But once we said, hey, we have RAL colors, we have really colors according to a color system, they are now ordering the colors because they know it from other industries. And why not having it for 3D printing? So the trend is very clear here, yeah.
All right, and Ken, you also shared an interesting application that touches on Dominik's the other day as well, which is referencing electric vehicles, that I would like for you to share a part of that story. I think it's pretty interesting for people as we're all seeing such an increase in electric vehicles.
Yeah, one of the things especially we're seeing now is, needless to say, UL is built on safety. With the move with the electric vehicles, one of the biggest things that the first responders have is disconnecting that electrical supply. And the industry adopted a specific color, safety orange, to designate high voltage components within the electric vehicles. And what's happening now is that color is really important, not only as a look or a feel for aesthetics, but now it's also that color has a really important play to assure that first responder can disconnect that power supply and know what's the high voltage of that to protect themselves further. So that's where those colors can really play an important part.
I thought that was very interesting. So I'm going to move over to some Q&A that we have out here. So one of them is, can you share some personal experience of AM pieces where color 3D printed parts allowed to avoid painting process? Which almost all of Dyemansion is dip process, correct?
That's fully correct, yeah. So we are using a water-based process called deep dye colorings, where we infiltrate color into the part, about 0.2 millimeters. And yeah, so the question is about where does coloring replace spray painting? Is that correct, in a nutshell? Or
close enough,
less?
yep, to avoid the painting process.
Yeah, I mean, one very big example, once again, is Daimler EvoBus. So they completely rely on the coloring of parts instead of using spray paints. So it was a long journey for us to meet the corporate colors of Daimler. And we worked very closely, not only with Daimler, but also with EOS to implement these processes on site. And so this is a very good example. So we met the Daimler corporate colors. They are then colored with this process instead of spray painted. So, yeah.
Dominik, do you have anything to add to that?
Yeah, also what I experience is that dip dyeing gives the most flexibility because sure, at the moment we're handling a lot of let's say copy-paste approach. So we're taking a part which is supposed to be designed for injection molding, and then we'll put it in this additive world. But also, as soon as also parts are designed for additive, they're getting even more complex and complex and complex. So it's going to be even more difficult to spray them, to have all these undercuts, lattice structures, all the things we will do in the future. And I think dip dyeing gives the most flexibility here to have a homogeneous coloring for the parts. So for me, it's a quite good fit for additive manufacture part.
All right, I'm not sure. Oh yeah, all right. So the next question is, how will you manage quantity of color in powder-based fusion technology? Ken?
Again, there's two different processes. One is the color being embedded in the material, as we talked about, and the other is the applications of applying the color afterwards, the dye stuff and the post-processing. We actually do address both processes in our evaluations, where the dye stuff and the really good part is the dye stuff that is in a water-based system requires very little evaluation. So in other words, because it's an after process, it's only penetrating a certain level of the material. There's a very limited amount of testing that needs to be done. Chemical processing may require a little bit more, but that's how we're actually looking at that, to make sure that that color is imparted and it's not going to significantly affect the performance of the plastic.
All right, Dominik, Max, do you have anything to add to that question?
Nope, nothing to add from my side.
That's good.
No? All right, so next up is, do you see an opportunity for direct color printing solutions for qualification programs and serial production? And then it has examples of machine, Stratasys.
So yeah, maybe I can say something from a machine manufacturer point of view. As EOS, we are producing the machine actually as well as, and today white materials are available, black materials are available. So what we do actually is we put in pigments into that material to make it black, grayish, whatever. Theoretically, from a development point of view, it might be possible to have colored parts for the powder, but then we really do need the business case there, because you can imagine if we develop that material, so we need different heating devices, or because the observation of the material and the reflection is differently, and also the business case or the application needs to be there, because we need to make sure that we can deliver that high amount of material. So from a theoretical point of view, we can color the material to have to produce colored parts. But today, in terms of pieces, amount of pieces for application, dip dyeing as a post-processing step is way more flexible and adaptable. No
That's
doubt
what I
about
was going
that.
to ask, Dominik. So versus the piece being produced that way from the start, it seems to be if you're going to use it in production like you're using with Daimler, that it would be better to have it be part of the post-processing process right now, such as the dip dye versus out of the direct printer. Do you understand what I'm saying? Like you keep the part in Daimler. So it seems to me that, you know, many of the machines right now can direct color print, right? But it feels to me like some of the best use cases in production parts, such as the parts that are in the Daimler vehicle, that it is better for it to be dip dyed versus coming directly out of the 3D printing machine, correct?
Correct. This is also what we see, because the flexibility is way better there. If you have an Evo Gray 1 or 3 or whatever you need, and also maybe the colors are changing, or the flexibility is way better. Much better to do a process, hopefully.
Next question. If there were one part there required different colors, then what? I'm not understanding the question from this person. If one part there required different colors, then what? Maybe that person can jump on and expand on that. But I'm not quite understanding the question that they're asking. If in one part there required, oh, I get it. If there was one part.
you.
Yeah, and it required different colors, but it's one part. Okay, gotcha. Sorry.
Okay, so this is about multicoloring a part, right?
I believe so. The question just went away, and the person wasn't asking, but I think if there's one part, how do you do multicolor?
Yeah, so at least with our process, as it's a closed process working with temperature and heat, the parts that are in the dyeing bath, they all get the same color. So what you can do is in the design or in the printing part of it, you can separate these parts that should have a different color and then separate them, and then once again connect them. But multicoloring is, at least with our technology, not possible.
Okay. All right. Well, we're wrapping up. Is there any last minute comments from anybody? Our time is up.
Thank you very much. Thank you to Links 3D and SME and Rapid and everyone for setting this up. It's really great to be part of this.
Thank you to all of you for being a part of it as well, and all of the audience out there from all over the world. Have a great day.
Thank you very much, and we hope to see some of you in the beer garden later on.
Yeah.
Sounds good.
For me, it'll be early.
Hello again, guys. I'm Lucia from 3D Natives. I will present you our next conference. This is, well, we will keep talking about color 3D printing. So in this case, the guys of Dyemansion will talk about the subject into a colorful future, how colors bring 3D printed products to life. Hello, Michael. Hello, Connie. So today I will present you. So after her biology studies, Connie will join Dyemansion as an R&D engineer with a focus on color development. She created the neon color line, cool, and works closely with the customers on the projects that require color matching or consulting. The case of Michael Shore has 7 years experience in the world of additive manufacturing with a focus on hybrid tooling, design for manufacturing, materials, prototyping, and scaled production. He possesses a strong skill set geared towards end-use products and application-specific goals. Very, very good. So guys, as you know, I will leave you here for the presentation and see you in a few minutes for the Q&A session. Okay, enjoy your presentation. Connie, I think you have to activate your microphone on the down. Okay, great. Now.
Yeah. All right.
And we can see Michael's screen correctly. Okay, good. Good.
Excellent. Well, thank you very much for the introduction there, and thank you for everyone who's joining us across the world right now. It's a little bit early on my side. The sun is just...
Sorry to interrupt again, Michael, but I think your sound is very, very low. I know. Now I think it's better. I don't know, but you have to activate your micro. Try to speak.
You're also muted, Mike. And you're muted right now. We can't tell. Okay.
If you click down on the micro, you see it on green.
Okay. Connie, would you like to start? And I'm going to just contact Michael just to make sure he's all good.
Oh, I don't have the presentation right here, so it's a little bit difficult for me to start it.
Okay, just a second, everybody. We will come back.